Hello everyone. Today we'll discuss about the light and sound which are often compared on various bases. So let's start with definition. Sound is the longitudinal emission that produce sensation of the hearing. Next parameter is the nature of its wave. These are the longitudinal waves consisting of compression and rarefaction. You can see that here there is more crowd of waves, so it will have more frequency. It's repeating itself quite often, so it has more frequency. So क्राउडी नेचर है इसलिए यहाँ पे कंप्रेशन, यहाँ पे देर इज bit more distance between two waves. It has more wavelength, and they are repeating less often as compared to this. So it is having rarefaction. So compression, rarefaction. These kind of waves repeat itself in compression, rarefaction. Compression, rarefaction. By the way, waves are of two types: mechanical waves and electromagnetic waves. Mechanical are further classified as transverse and longitudinal, and electromagnetic waves is another category. So for mechanical waves propagation, it requires the material medium for propagation, and electromagnetic waves don't require such any medium. So these waves can travel through vacuum also. So next point is that these waves require the material medium for its propagation, so cannot travel through vacuum. Okay. Next one is the speed of sound and nature of sound. So sound exhibits a single nature, which is a wave nature. Sound exhibits a single nature, that is wave nature. Next is speed of sound. It is speed of sound is variable in a medium, and it changes with temperature, as c is equal to root over gamma rt, where c is the speed of sound in meter per second, gamma is adiabatic index, r is characteristic gas constant in joule per kg Kelvin, and T is the temperature in Kelvin. So for air at 273 Kelvin, that is 0 degree centigrade, C is equal to root over gamma का वैल्यू होता है 1.4, R का वैल्यू होता है 287 जूल पर केजी केल्विन, और T का वैल्यू है टेम्परेचर 273 Kelvin. On solving, approximately you will get speed of sound as 332 meter per second in air. So if the medium is same, but if I keep on changing the temperature, speed of sound will also change. Okay, and speed of sound is maximum in steel. Now let us compare or define light and same medium or same basis as on sound. First one is again definition. It is an electromagnetic emission. It is the electromagnetic emission that produces the sensation of vision. These are electromagnetic waves consisting of varying electric and magnetic fields. As I told you earlier, that electromagnetic waves do not require a material medium for propagation, so they can travel through vacuum also. Light exhibits a dual nature, that's particle and wave. The particle nature was given by scientists Newton and Maxwell, and wave nature was given after some many years by Hygiene, Huygne, Hygiene. And speed of light is constant in the medium, and its maximum for air, and its value is 3 lakh kilometer per second, or 3 into 10 to power 8 meter per second in air. When medium will change, speed of light will also change. Now we'll discuss the very important concept, that is Doppler effect. Doppler effect was first found by a scientist named Doppler for sound, and later he applied the same for light. So if the sound source or the observer or both of them are in a state of motion, or either of them are state of motion, frequency of sound will appear to be changed. Such a phenomena of apparent change in the frequency is called Doppler effect. For example, you are sitting in a stationary train and you hear the whistle of another train coming towards you. So first of all, when the train will approach you, you will hear the sound of increased frequency. And when you will, or the train, when the train will move away from you, you will hear the sound of low frequency. But actually, the frequency of the source of sound, its train, is constant. But since the train is moving and you are stationary, so when the train will approach towards you, the speed will, oh sorry, the frequency will increase, and when train will move away from you, frequency will decrease. So if a source of sound and the observer approach each other, the frequency will increase. But if they move away from each other, frequency of sound will decrease. Okay. Now let us see Doppler effect in light. So as I told you earlier that when the frequency of sound, sorry, when the source of sound is moving, the frequency will change. So on exactly on similar lines, when the source of light is moving towards or away from the source or observer, the frequency of emitted light will change. Also, subsequently, when the frequency will change, the color will also change. So the spectrum of light of color is V for violet, I for indigo, B for blue, G for green, Y for yellow, O for orange, and R for red. As you move from V to R, that is violet to red, the frequency of light will decrease and wavelength will increase. The speed, the and frequency and wavelength both are related by the equation called as C is equal to mu into lambda, where C is speed of sound, mu is frequency, sorry, C is speed, mu is frequency, and lambda is wavelength. This equation is valid for both light and sound. C is equal to mu into lambda. You can see from this equation that frequency and wavelength are inversely proportional. मतलब जिसका फ्रीक्वेंसी ज़्यादा उसका वेवलेंथ कम, या जिसका वेवलेंथ ज़्यादा उसका फ्रीक्वेंसी कम. ओके, सो एनी शिफ्ट टूवर्ड्स द लॉन्गर वेवलेंथ will have red shift. Longer wavelength माने कि small frequency. So red has more frequency, so it will have red shift. And when it will move towards shorter wavelength means before red in spectrum, it will have blue shift. So when the source of light moves towards us, means the frequency will increase but wavelength will decrease. So it will have the blue shift, because blue light has short wavelength than red light. And when source of light is moving away from us, that means frequency will decrease and wavelength will increase, so it will have red shift. Now one fact is that the color that spreads more can't travel long distance. It means that the color that spreads more has short wavelength. So violet color spreads more, it has short wavelength, and red color spreads less and has longer wavelength. That's the reason behind the traffic lights being red, yellow, and green. Okay, so that's all in this video. Thank you for watching this video. If you gained valuable knowledge from this video, kindly like the video, share the video, comment on the video your views, and subscribe to my channel and hit that bell icon so that whenever I upload the video you will get the prior notification. Thank you.